So when we come back to fractions now, we have this question where you need to be able to compare fractions. So in comparing fractions, you want to be using symbols like less than or greater than, right? Less than, greater than, or even in some cases equal, right? So this is going to test your ability to identify fractions that are equivalent, fractions that are larger, fractions that are smaller. Now in our statement here, we have 4/6 and 2/3, right? And the only way that we can compare these fractions is if we bring them to come. So what you want to do, you want to bring them to come out of a common denominator. That's the first step you should take, right? So we could probably tell ourselves that because the number 6 looks larger, 4/6 is a larger fraction, but that's not really the case, because when we bring them to a common denominator, we'll be able to see which fraction is actually larger or smaller, or if they are both equal. So you come like this, right? Let's just say we have a chocolate bar, right? So very crudely constructed chocolate bar, but let's just say it was divided into 3 equal parts. And I said, well, I'll give you 2/3 of this chocolate, right? So this is your portion, this is 2/3. But what if I come down and say, well, I'm going to share another chocolate bar, right? I'm going to share another chocolate bar. And in sharing this other chocolate bar, what I realize is that the chocolate bar isn't divided into 3 equal parts. It's actually divided into 6 equal parts, right?
Yep.
So if I tell you that I'm going to give you 4/6, right, of the chocolate bar, you might think, well, the 4/6 sounding like the bigger portion, so you get more chocolate in comparison to where you were getting 2/3 of the other one. And you might tell yourself, well, maybe I should just take the one where I get the 4/6 because I get more chocolate. But I want you to just do a visual comparison, right? A visual comparison in terms of you're looking at the chocolate that's divided into 3 equal parts versus the chocolate that's divided into 6 equal parts. And what you're actually going to realize is this: although very crudely constructed, but although 2/3 sounds smaller, it's actually very much representing the same portion as the 4/6. So it's not to say that 2/3 is larger than 4/6, but to prove that 2/3 is not smaller than 4/6, or 4/6 is not larger than the 2/3, what we have to do is bring them to
equal.
Yeah, you want to bring them to equal fractions, equivalent fractions, right? So we're going to show that it's equal by doing this. You're going to bring 4/6 and 2/3 to a common denominator. So I want you to tell me, what number can both 6 and 3 go into without leaving a remainder? So this is why we were talking about 3 times tables earlier, right? What number can you divide by both 3 and 6 and not leave a remainder? So I want you to think about your 3 times tables, and then I want you to think about your 6 times tables. And I want you to think of the smallest number in each timetable that you see in both of them. So for example, call out some multiples of 3 for me. What are some multiples of 3? So remember your 3 times tables from this morning. What numbers did we say belong to the 3 times tables? 6, right? 3, 6, like that, yeah. So 3, 6, what else? 9, 12, 15, right? So you could recite the entire 3 times tables. Now I want you to go to your 6 times tables, because this is where we're going to narrow down which number we're going to put as the common denominator. So 6 times tables, your multiples are 6. Tell me a few of them. 6, what's next?
6,
12, 18, right? So 6, 12, 18, 24. Those are also numbers that you could find in 3 times tables. But which of the numbers that you just recited did you find in both of the timetables that is the smallest of all the numbers that you find in both timetables?
6.
6. So that means 6 is our common denominator, right? 6 is what we call the LCM. So we always want to remember that we use the LCM to bring fractions to a common denominator so that we can compare these fractions easily, right? Now we can create two equivalent fractions out of 6 to compare these two fractions. Now 4/6 is already out of 6, isn't it? Because its denominator is 6. So 4/6 is already out of the fraction, out of the denominator that we want, but we need to convert the 2/3. How many times can 3 go into 6? So remember this morning we talked about this as well, right? We set the timetables, we said 1 3 is 3, 3 into 3 is 1. So 2 3s are 6, 3 into 6 is 2. We're going to take that factor of 2 and you're going to multiply your numerator by 2. So what is 2 times 2?
4.
4. So look at that, right? 2/3 has the same numerator like 4/6. So do you think that 4/6 is still larger than 2/3?
No.
No, they're not. So
Because they're equal.
they're both equal. So what symbol are we going to put in the box up here?
Equal.
Equal, right? So we can see that 4/6 and 2/3 are actually equivalent fractions. And like I was saying, that process, you always want to make sure that you remember whenever you have fractions and you need to compare them, you bring them to a common denominator. Alright? So this was well done.